So now we are going to do section 2 of chapter 23, and this is about what happens in massive stars rather than low mass stars. So last section we talked about low mass stars, and they, lose their outer layers and look increasingly hot and then cool down over billions of years into a white dwarf. So instead, now we're going to look at the inside of a massive star and the steps of the core collapse. For a massive star, the weight of the outer forces causes this carbon-oxygen core from last time to continue to heat up, and it becomes hot enough to fuse that carbon into oxygen, neon, and magnesium, and then continues, and the oxygen, neon, and magnesium heat up and fuse into silicon, sulfur, calcium, argon. So this repeats over and over and over. You get silicon in the core, and then it heats up enough that the silicon fuses into sulfur, and it heats up enough that the sulfur fuses into calcium. So it goes on and on and on until you get to iron. Iron is important because to fuse two iron molecules to each other, you have to add energy to the system. And that does not happen in nature. So, the massive stars, truly massive stars, go through these final stages in months and potentially even days. And once we have an accumulation of iron in the core, the star is, it's done for. It has no option but die. And so we have had electron degeneracy pressure in here all along, helping push out, in addition to the heat. Once there's a significant amount of iron in the core, there is no fusion and nothing happening. So once again, there's no heat, thermal pressure pushing out. So we have gravity pushing down, and the electron degeneracy pressure just fails. It cannot push out anymore. And so those electrons that were going, no, 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 I'm not talking to you, are pressed together so hard that they fuse into neutrons, neutrinos, protons, and so we end up with a neutron star. And yeah, I don't remember what I was going to say there. So the neutron star, let me add a couple of things. We talked about a teaspoon of a white dwarf will weigh as much as a semi-truck. A teaspoon of a neutron star will weigh as much as Mount Everest. So really, really dense, immensely dense. So that's the end of that one, and we get to talk next about supernovas and what happens when that very massive star explodes, because they're super cool.